Okay, question 10. Three forces of magnitudes 4, 6 and P are acting on a point in the direction shown in the diagram. The forces are in equilibrium. Show that theta is 41.4. Now this is a show that question, so we're not allowed to use theta equals 41.4. We've got to arrive at that as our answer. So we're thinking about what's going on with the forces. I am thinking that if it's in equilibrium, the resultant force in any direction is 0. So if I resolve horizontally, if I resolve in that direction, the resultant force is 0. So that tells me that 6 sine theta, because I'm interested in that bit, in the opposite bit, must be equal to 4 sine 2 theta. So I've got that statement to start with. Now we've just got a bit of pure maths. We've got to solve that equation. Sine 2 theta, that's the double angle formula, isn't it? So what we're going to say here is that 6 sine theta is 4 times 2 sine theta cos theta. Sine theta cos theta, sorry. That's just using sine 2a is 2 sine a cos a. We've got a common factor of sine theta on both sides of this expression. So we end up with 6 is 8 cos theta. So cos theta is 6 over 8, or 3 over 4. At which point we do inverse cos, that's the theta in there, inverse cos of 3 over 4. And our calculator says 41.4 degrees. The three significant figures. And there we go, that's the 4 marks for that. Interesting that in a mechanics question, we've got the bit of pure maths, that is the double angle trig identities that we've learnt. But anyway, there we have it. Hence find the value of P. We now know what theta is, so if we resolve vertically now, then we should be able to work out what P is. If we resolve vertically, we've got 6 cos theta plus 4 cos 2 theta and that's equal to P, because P is the only force that's acting down, so minus P equals 0. Outrageous. We know what 41 point, we know the angle, we know what theta is, so we could just throw that into a calculator, couldn't we? And do, if we save that angle, then we've got 6 cos theta plus 4 cos times 2 theta. Come on, that's it. And that gives us 5. P equals 5. That was nice, wasn't it? Great. You didn't have to do anything more fancy than that. It wasn't a detailed reasoning question. Then we're on to part 3. The force of magnitude 4 newtons is now removed, and the force of magnitude 6 is replaced by a force of magnitude 3 in the same direction. Find the magnitude of the resultant and the direction of the resultant. So I feel like I need a diagram. So the force of magnitude 4 is removed, and the one 6 is replaced by a 1 of magnitude 3. So we've got 3 at an angle of theta, and we've still got P. It hasn't said anything about P, and we found that P was 5. So if we start to work on what we've got going on with this, then there are a number of ways that you could deal with this. I feel that I want to do resolve in the 2 directions and find my 2 directions and then go from there. So in the horizontal direction, I have the force that's across is 3 sine theta. I also have that in the vertical direction, the force that's vertically upwards that would replace it is 3 cos theta take away 5. And so shall I actually work out what these are? 3 sine theta, it's the sine theta, is 1.984, and 3 cos theta take away 5 is minus 11 over 4, or minus 2.75. So the magnitude is the square root of 1.984 squared plus minus 2.75 squared. So that is going to be the square root of 3 sine alpha, or when we square it, plus 2.75 squared. That's the other one. And that gives me root 46 over 2, which is 3.39. 3.39 newtons. What I've just established in this, for the final part of this question, is that I've got a force there that is 1.984. I've got a force there that is 2.75. That was my resultant force. I want to find the direction of it, and I need to talk about what direction that is. So let's call that the angle that I'm dealing in. So tan alpha is opposite over adjacent. So alpha is the inverse tan of 2.75 over 1.984, which gives me an angle of 54.2 degrees. So it is 54.2 degrees below the horizontal. You need to make some reference as to where that force was coming from. You could talk about it being whatever that would be, 35.8 degrees from the P force, or something like that. Kevin's about to argue that he has all the marks for that. There we go.